All right, this is 2.5 part B. We're going to be solving equations algebraically, and specifically we're looking at rational functions. That means fractions, people, fractions. So we're going to do rational functions and work on how to solve these the easiest way possible. Okay, so let's get after it. All right, so looking at this guy, see they're rational. X is in the denominator. There's denominators, so we do not freak out. We just handle these fractions. Now the easiest thing to do to get rid of fractions is to multiply both sides of the equation by something that will get rid of the denominators. Okay, and 99% of the time, all that's going to be is the product of the denominators. Okay, so product means multiply. So look at my denominators. This is a x and a 2. So if I multiply both sides of this guy by 2x, let's see what happens. All right, so on the left, I'm going to get 2x squared equals. Now on the right, if you want to spell it out, I'll have 3 over x times 2x plus 1 times 2x over 2. All right, so that would be 6x over x plus 2x over 2. But look, those reduce, right? Those x's go away, and that becomes a 6. And this 2's cancel out, so this just becomes plus x. Easy enough. Look, fractions are gone. Now we want to solve this. My x squared term's over here, and it's already positive. It's positive 2. So I want to leave it on the left. I'm going to move these pieces over. I'm going to subtract x. So I have 2x squared minus x. And if I move the 6 over, I'm going to have minus 6. Minus 6 equals 0. So there I have it. Now I'm going to use what I know about factoring. Okay, so I'm going to take multiply times negative 12. 2 times negative 6 gives me negative 12. And I want two numbers that multiply to that but add to negative 1. If you think through your factors, I get negative 4 and a positive 3. All right, that's all good. Now, I'm going to need a box though. Let's put this in the box. So I need negative 4x, 3x. 2x squared goes here, and negative 6 goes here. Now I think greatest common factors by row and by column. So doing this first column first, let's do, I get an x they have in common. Over here, it's going to be a negative 2 they have in common. Top row, I can take out a 2 and an x. The bottom, I can take a 3, and because this 3 is positive, this is going to be positive. So now, this becomes 2x plus 3 times x minus 2. There's my two factors, and it's still equal to 0, so I'm going to set each individual factor equal to 0 and solve it for x. So I have 2x equals negative 3. Divide by 2. So x equals negative 3 halves. And this becomes x equals 2. So there's my two solutions. All right, there's my two solutions. Let's try the next one. All right, so again, get rid of the fraction by multiplying by whatever the denominator is. So think of this as x over 1 if you need to. To get rid of the denominator of x, I just need to multiply both sides by x. On the left, these will cancel out, and I'll have 20 minus x equals x squared. Fractions are gone. Again, I want to leave the x squared term positive, so I'm going to leave that there, and I'm going to move the negative x over by adding x. So I'm going to have x squared plus x. And I'm going to move the 2 over by subtracting 20. Sorry, move the 20 over. All right. Now I need to factor this. So I'll have x and x, two numbers that multiply to negative 20 but add to 1. So it'll be a negative 4 and a positive 5. All right, so still equal to 0. So we set each factor equal to 0. So x equals 4 and x equals negative 5. And there's my two solutions. Super easy if you get rid of the fraction first. All right, let's look at number 3. This is a little more complex, but we can handle this. All right, let's get rid of our fraction. So I'm just going to rewrite things over here so we can talk about what's going on. Remember, product of our denominators is what we want to go for. So if we multiplied our denominators together, we would have x times x plus 1, right? That 1 doesn't change anything. So if I multiply all of these, if I multiply this by x plus 1, x plus 1 over x, and I multiply this over here by x times x plus 1 over x plus 1 equals, and I got to multiply it all the way over here too. This becomes 3x times x plus 1. All right, now let's clean it up. These x's here cancel out, and I'm left with x plus 1. Over here, the x plus 1 binomial cancels out, so I'll have minus x. And over here, it's all going to be there, x 3x times x plus 1. So let's see what happens here. We have x minus x. Those cancel. So I have 1 left over on the left. Here I'm going to distribute that 3x. So 3x squared plus 3x. All right, now we're getting closer. Here's my x squared term. It's positive. I want to leave it positive, so I'm going to move that 1 over. So I'm going to have 3x squared plus 3x minus 1. All right, so it's a binomial or trinomial. Let's see if we can factor this. If we multiply a times c, we get negative 3, and they have to add to 3. Well, the only factors of 3 are 1 and 3. They don't add to 3, so factoring isn't going to work. So what could we use? We can use quadratic formulas. So we need to isolate. Okay, a is going to be 3, b is 3, and c is negative 1. So if I use good old quadratic formula, x will equal, remember it's negative b plus or minus the square root of b squared minus 4 times a times c. All of that over 2 times a, which is 6. All right, so let's clean this up a little bit. Under the radical, we have 9 minus 4 times 3 is 12, times negative 1 is negative 12, times this negative 1 makes that plus 12, which is 21. So I have negative 3 plus or minus the square root of 21 over 6. And that doesn't reduce in any way, so here's my solution. This is it. All right, that is my solution. Kind of messy, but that's my solution. All right, on number 4. Okay, let's try to simplify this guy and get rid of the fractions again. Let's try to clean this up, get rid of the fractions. Now, let's see, t squared is here and t is here. If I multiplied through by t squared, I could get rid of the fractions. I don't have to do t squared times t because I don't need t cubed. That would mess me up. I need it to stay t squared. Get rid of that denominator. So I'm going to multiply everything in there by t squared. And let's walk it through and I'll show you what I mean. All right, so now I have t squared over t squared plus 8t squared over t plus 15t squared over 1. All right, clean it up. Now look, this becomes a 1. These t's, all that's left is 8t, right? And here I have 15t squared equals 0. The fraction's gone. We are in business. So now it might be easier in this regard. The square term's in the back end. Let's flip it around. Everything's positive, so it's easy to flip. Let's flip it around so the constant is on the right. It's easier to see. And let's think about this. We want to multiply a times c is 15, and they need to add to 8. So factors 15 are 3 and 5, and sure enough, they add up to 8. So we are in good shape. Now, when I box this, let's see what happens. I have 15t squared. This is a t, this is a t, and this is a 1. So when I pull out my factors, let's see, That's going to be a 5t. That's going to be a 1. It's going to be a 3t, and this is going to be a 1. So I'm going to have 5t plus 1 and 3t plus 1, all equal to 0. And then I set each factor, like I've always done, equal to 0 and solve it. So 5t equals negative 1. So t equals negative 1/5. 3t plus 1 equals 0. 3t equals negative 1. And t equals negative 1/3. All right, there it is. There are your two solutions. Okay, let's try another one. Let's see, what can we multiply through by to get rid of our denominators? All right, so I'm going to rewrite my problem. Feel free to pause the video and try it on your own, or keep watching. I think if we multiply through by x times x minus 2, we're going to be in some good shape. So if I do that, these x's cancel, and I have 2 times x minus 2. Here I'm going to have 3x times x minus 2 over x minus 2 minus x times x minus 2. Now, these cancel out, and we can clean this up. We got 2x minus 4 equals 3x minus x squared plus 2x. All right, so we clean this up a little bit. Combining like terms is our goal here. So let's do that. Let's put our 3x and our 2x together. I get 5x minus x squared equals 2x minus 4. Now notice my x squared is negative over here, so I want to move that over here and make it positive. It's going to be x squared. And if I subtract 5x from both sides to move it up, I'll have negative 3x minus 4. And then it would be equal to 0, and we're in good shape. This is factorable now. We multiply 1 times negative 4, but they add to negative 3. So it's 1 and 4. So this is going to be x plus 1 times x minus 4 equals 0. Set each factor equal to 0. Solve it for x. So I have x equals negative 1, x equals 4, and there's my two solutions. It's all about picking the right thing to multiply through by. Okay? If you don't see it at first, go just do trial and error and you'll begin to see the pattern. Last example. All right? Let's try this. Okay, so I would multiply by the product of these two puppies. So it would be x times x plus 3 all the way through this guy. All right, so let's do this. So if I multiply that, I'm going to end up with 4x times x plus 3 over x plus 2x times x plus 3 over x plus 3 equals negative 3x times x plus 3. All right, so clean it up. These x's go away. So I'll have 4x plus 3, 4 times x plus 3 plus 2x, those x plus 3's cancel, equals negative 3x, x plus 3. Okay, so now I want to distribute through, so I'll have 4 plus 12 plus 2x equals negative 3x squared minus 9x. So I want to combine like terms. I want to move that 3x squared over here. So I'm going to have 3x squared, see, plus 6x plus 12 equals minus 9x. So if I add 9x to both sides, I then have 3x squared plus 15x plus 12. All right, so I can start factoring, or I can just stop and realize I can factor a 3 out of everything. If I do that, I'm just going to scooch over here. I then have x squared plus 5x plus 4. And that's a lot easier to factor than something with a 3x out front. So I'm going to leave the 3, and then this guy factors down to x plus 4 times x plus 1. And then I'm going to set each part equal to 0. Now, 3, we know, does not equal to 0. So this is not going to produce a root for us, so it doesn't really matter. X plus 4 equals 0. X plus 1 equals 0. And we can solve that. So these problems are going to have a lot of steps to them. So you're going to make sure you give yourself space and room and write legibly. Ask questions if you need to. Okay, it just takes some practice, but you're going to get this, no problem.